Okay, this is the Math 2460 Zoom session for November 24th, Math 2460. We're going to go over the final exam review and hopefully give you get an idea of what's on the final exam. We'll just walk through it. So problem one, we're converting to Cartesian coordinates. This is in polar coordinates, so this is an r and a theta. And so if you remember, your x went r cosine theta and your y went r sine theta. So you plug and chug. Cosine of 2 pi over 3 is -1/2, and sine of 2 pi over 3 is √3/2, and multiply those by 2, and it works out -1 and √3 because the 2's cancel. So your coordinate is -1 and √3 for an x and a y. I don't think this is exactly the same version of the dy dx formula in polar coordinates that we gave. I think it's from an older edition of the book, but it's identical. The terms on bottom may be switched. In fact, they are. The version I gave you, the f of thetas, the r's were first, these were second. But it doesn't matter. It's still the same thing. Remember, r is f of theta. So r prime would be twice cosine theta. Theta equals pi over 2. So plugging and chugging. I can go ahead and plug in for the r and the r prime just to shorten it up. R of pi over 2 would be sine pi over 2, which would be 1. That gives you 2 plus 1, which is 3. The r prime of pi over 2, cosine of pi over 2 is 0. So plugging and chugging, you would get 0 here for both these pieces. The r f of theta is 3 there, cosine of pi over 2, which is 0. And 3 times 1, sine pi over 2, which is 1. 0 over -3 is 0. All right, so number 3 is about working out a series starting from your formula we call number 2. Signs alternate. It's a power series with the alternating signs. Find a series for our tangent. Oh, we have a participant. You want to tell me who you are? Are you muted? I'm not hearing you. Are you muted? Make sure my volume's up. Yeah, my volume should be up. Can you tell me who you are? Do we have 2 more participants? Chat. Trying to chat too. Let's see. Oh, he's muted. Mr. Iverson. Okay, I see it. No problem. Can you unmute yourself? If not, no problem. I was just walking through the problems on the final exam review sheet. You're our first participant. Is there any particular problem you'd like to see? If you can, I've got the chat thing up here. If you can type me in the problem you want to see. If you want to see anything, or do you want me to just keep going through the problems? Don't have a particular one. Okay. So I'll just keep walking through the problems then. If you want to chat something at me, go ahead. Let's see, do we have anything? Okay, got it. So yeah, we were down on number 3. And so you want to put in 1 over 1 plus x squared. You want to put x squared in for the x, giving you this. 1 minus x squared, then x squared is x to the 4th, x squared cubed, x to the 6th, etc. And then you want to take an antiderivative of all of these. 1 brings back the x, and you're going to add 1 and divide by those. 5th over 5, x7 over 7, etc. All right. Moving on, number 4. Taylor polynomial of order 3 for 1 over x plus 2. So I'm going to switch it around and write it x plus 1 plus 1. Let's see, I'm using Taylor's full formula. So I can do it that way. F prime works like this. F double prime, triple prime is x, and F triple prime is 0. And I wind up with these. Number 5, alternating series test. Remember that I had 2 conditions. You want the limit of the terms. Do they go to 0? Yes. And number 2, 1 over n plus 1, the n plus 1 term is smaller than the 1 over n term. And sure enough, 1 over n plus 1 squared would be less than, I left off a square here. I should have had a square because it's 1 over n squared. So we can say it converges by the AST. If you actually want me to stop and work one of these out, I'll be happy to. Here's a ratio test problem. Remember, you take limit of an plus 1 over an. And so we get an plus 1 is on the top here, putting in n plus 1 for this. Divide by the nth term, which is what's given. If you collect these terms, spreading this out, n plus 1 times n factorial n times n factorial there, you cancel. This spreads out to e to the negative n, e to the negative 1, canceling e to the negative 1 n. We wind up with n plus 1 over e, send this to the bottom, and put in infinity on top. You'll get infinity, and you get a divergence. Terms are going to infinity. An integral test, meaning you want to take an integral of this. And so it's a u du substitution. U is x squared plus 1, du is 2x dx. And you have a fix of 1/2. Gives you 1/2 integral 1 over u, which is a half log u, which is a half log x squared plus 1. Plug in infinity, a half log infinity is infinity. So it diverges. Number 8, your sum on a geometric is a over 1 minus r. And the a is 8. Your r is 1/5. That's the easiest way to think of it. So 8 over 1 minus 1/5. 8 over 4/5, 8 times 5/4, 40 over 4 is 10. Let me check the chat line, see if there's any questions. Okay, not particularly. All right. Anytime you want to unmute yourself, if you can, help yourself. First 5 terms of a sequence, just plug in 1, 2, 3, 4, and 5 into this. So you get 3 to the 1, which would be 3 minus 1 is 2 over 3. 2, 3 squared is 9 minus 1, that'd be 8 over 9. 3, 27 minus 1 would be 26 over 3 to the 3rd is 27, etc. You'd have 3 to the 4th, which is 81 minus 1 is 80 over 81. And finally, 240. You see how the top is always 1 less than what's on bottom. evaluate this, this is a u du integral. Again, we're taking that to infinity, see if it converges or diverges. And so make your u arctangent. Derivative is 1 over 1 plus x squared. So it winds up being a 16 integral of u, which is 16 u squared over 2, which is 8 arctangent of x squared. Plug in infinity, 8 arctangent of infinity squared. Arctangent of infinity was pi over 2, if you remember that. Arctangent of 0 is 0. So I wind up with 8 pi squared over 4, 2 pi squared, and that's finite, it converges. Okay. Simpson approximation. Haven't written out the full Simpson formula. I don't know if you remember it. Maybe I should write it toward the bottom here. It was b minus a over 3n f of a plus 4 f of x1 plus 2 f of x2, and then you added on an f of b. So that's what I'm doing here. This is just the straight data. This would be your a, this would be your b, f of a, f of b, f of x1, etc. So you wind up with your b minus a, 24 minus 0. 3 number of intervals is 6 and 1, 2, 3, 4, 5, 6 is the spaces in between, 6 intervals. And so you wind up with 3 for your f of a, and wind up alternating, multiplying these 4 times 8, 2 times 12, 4 times 17, 2 times 23, 4 times 28. Tack on your f of b, which is 41. Multiply by this front coefficient. Hopefully it punches out to that. Let's see, it's really, I separate those. Your f of b is this. All right. 12, you work out this one with partial fraction expansion. We've got a lot of material in this class. So if we factor the bottom, you have an x minus 2, x minus 1. It's a distinct linear, a over x minus 2, b over x minus 1. Put it back together, remember cross pattern. A times x minus 1 plus b times x minus 2. You're going to set that top equal to the 5x minus 7. That's what I'm doing here. X equals 2 will tell me the a. And sure enough, I put it in really tight here, but you get 10 minus 3. 10 minus 7 is 3. 2 minus 1 is 1, so that's a. And x equals 1 will tell you the b. The a will die. 1 minus 2 is negative 1, so you get a negative 1b equals, put in an x is 1 here, you get 5 minus 7 is negative 2, so you get a positive 2. Put those in, and they work out straight logs. Antiderivative was very trivial. All right. 13 works out by parts. Make u the first thing 4x, du be 4, dv is e to the 3x, and on the antiderivative you divide by that 3. So if you remember, you had uv minus integral v du, meaning cross product minus integral bottom row. So 4x over 3 there, e to the 3x, there's your cross product. Minus bottom row is 4/3 e to the 3x. And you'll get another divide by 3 out of that antiderivative, 4/9 c to the 3x plus c. Arc length, I didn't write the formula in, but it was integral from a to b, square root 1 plus f prime of x squared and dx. So 1/3, you take a derivative and you get a 1/9. Well, I didn't write down the derivative. Oh, I think I wrote it over here. All right. your derivative is 1/3, you get e to the x and chain rule of minus e to the x over here. So when you square it, you get 1/9 e to the x minus e to the minus x squared. Hopefully you can punch that out and you get this. All right, 15, washer method. And I have the formula here. Y is x squared around y equal -3 horizontal line below. And your outer radius, you draw them on out, but you'd be 3 plus, and then y, 3 plus y is 3 plus x squared, and your inner radius is just 3. And so plug and chug, 3 plus x squared, then square, minus 3 squared, and hopefully you get to punch out to that. All right, an integral like this, see how derivative tangent is secant squared? U is tangent, du is secant squared, but you got a chain rule term. So it subs in as a half integral of e to the u, and all this stuff outside is du. Fixed as a half e to the u, half tangent 2x plus c. I don't know if I'm going too fast or anything, not getting a lot of feedback. If you got any questions, should I check for questions? Oh, okay. So we'll have one more Zoom session next Tuesday, just ahead of the final. We'll pass out the final next week. All right, 17. This is from chapter 5, kind of a trig form. Make your u squared x minus 3 squared here, put a single letter there. Your u is x minus 3, your du is identical to dx. And then x is u plus 3 from this line, so you can put that in for the x, plus 5 square root of 9 minus u squared. That makes u plus 8. You'll split it up, straight u du plus your 8, integral of this. That's a straight arc sine with an a of 3, if you remember how that worked. Just get an arc sine of u over 3, coefficient of 8. The front one works by a quote u du, but I use letter a. 9 minus u squared dA is -2u du. And so you get an 8 to the half, and 9 minus u squared to the half. And yeah, finally over here, negative, plug back in, u is x minus 3. And get this. On 18, eliminate the parameters. So that's from chapter 10. You always start with your x equation, solve it for t. Divide by 2, take a cube root. T is the cube root of x over 2. Plug that into your y. Cube root of x over 2 to the 4th. You can make it x over 2 to the 4/3. Add 1. So that's your direct function mode equation, and here's your parametric equations. 19, they want you to find dy dx, and you do it from direct y derivative, direct x derivative, and plug in pi over 6. So your y derivative is 2 secant squared, derivative tangent is secant squared. Your x derivative is derivative secant is secant tangent. Plug and chug, and I wind up with 2 over sine. Plug in pi over 6. 2 over sine pi over 6 is 2 over a half. Flips around. Wind up with a 4. Finally, number 20, convert this equation to polar form and sketch its graph. Sine theta x equals r cosine theta. So I'm putting in r squared sine squared theta here, 9r cosine. Solving for r, one of the r's cancels, and I get r is cosine over sine squared, which winds up being 9 cosecant squared cosine. Flip it up, or you can leave it like this. And then I entered that in a window, and you're going to be in polar mode. And it gave a graph like this. You might recognize it, sideways parabola. Not a function, does not pass the vertical line test. That's about it. Did you have anything else you wanted to ask? Want to chat at me? Otherwise, I'm going to end the meeting. I'll hold one more Zoom. People may not have been into the final this quick. So I'll probably hold one more Zoom, give everybody a chance to look over the review, look over everything, and hold one more Zoom meeting, probably the Tuesday, regular schedule, like Tuesday of finals week. Maybe people have more questions, more people might come out. But with any luck, that might give you a good idea of what's on the final. You have anything you want to ask or say? I'm looking at your chat line. Okay, we'll see you then. We're going to end the meeting.